Good morning, everyone. Thank you for joining Flex Train, a training opportunity brought to you by Johnstone Supply. So I want to dive into condensate pumps a little bit and talk about the selections and the use of condensate pumps, because there's a whole variety of pumps that are in the industry, and what works best for you will really depend on a few things. It's going to depend on the amount of condensate that's going to be produced and how far we need to push it and what type of equipment we're working with. So let's just look at some of the history of condensate pumps, where it actually came from. I love talking about history. I love diving into where we came from so that we know where we're going. Well, even just Wikipedia has a lot of information on condensate pumps, and they talk about that it is an electrically powered centrifugal pump used to remove condensate water from HVAC systems. And that's really where we got our beginnings. We got our beginnings in boiler systems, because if we think about boilers, a lot of times with boiler operations and with steam driven and even hot water driven heating systems on hydronic systems, a lot of times we have places that we need to bleed off water. And when that water is in places that doesn't have a place of natural gravity to get to a drain, we've got to get that water out of there. So we use centrifugal pumps with some type of a reservoir. Now, how big of a pump do we actually need? Well, that's going to depend on how much water we're actually producing. So let's look at the internals of a pump and see what they have. And I know these aren't the best pictures in the world. I actually got a hold of Little Giant to try to get an original copy of that condensate pump, and their marketing director is no longer with the company, and no one can seem to find the original picture for it. So that's the best one that we have, but they really have some cool cutaways of their pumps, so you can see exactly how they're constructed inside. So really, we're just going to use some type of a reservoir that has typically a float switch, and then we're going to use some type of a motor that is going to turn a pump. And most of the Little Giant, they're using a stainless steel shaft because it is actually sitting in water, and then just got a plastic impeller. So it's just a standard water pump. But if we look at the motor design on that, most of these are using a shaded pole motor. So the downfall of the shaded pole motor is they don't really have a lot of torque to them, right? So they have some RPMs, and they're fairly easy to construct and design the horsepower, but they don't have a lot of torque, which means as we start increasing the amount of height that we need to move that water, a shaded pole motor is going to start struggling. It's going to slow down the gallons per hour of water that is going to move. So we have to know exactly how far vertically we're moving that water. Horizontal has some effect to that size selection, but the most important is how far vertically are we going to go, because the type of motor is going to change how much torque we have, how much force we can create to move that. And remember, we start talking about motors, we've got shaded pole motors, which are the lowest torque and probably least efficient, but inexpensive to manufacture. We have permanent split capacitor motors, which are basically a 2-speed or has 2 windings, so has a decent amount of torque and has a fair amount of RPMs as well, because it's moving between 2 windings. And then we can get into ECM or variable speed style motors, which is the way to go, right? That's really, love ECMs. So thinking about that, thinking about the style of motor that is in that pump is going to help us decide what pump is going to work best for us. And then typically we're going to use, like if you look at that one on the right hand side for that Little Giant, on top of the motor, they actually need to install a cooling fan. And that cooling fan is there to help remove heat off from that shaded pole motor. And then we're also going to use a check valve inside of that so that we can maintain, once we start moving our water up, just like a well design. As we pull our water up, as soon as our pump stops running, we don't want that to all drain back down, because then we're going to have an additional force to fill that all back up before we can pump it out. So knowing that there's a check valve in there will help us understand when we have failures in our pumps, because I've seen pumps out in the field that gets debris or gets sludge built up in that check valve. And once it shuts off, that trough will start filling up, and you'll know it. You'll hear that pump cycling a lot. You'll hear it pump out and it'll shut off. And then a short period later, it'll start pumping again. So if you have a condensate pump that is cycling irregularly, It's probably in your check valve. Good time to pull that apart, clean it, or replace it. Good practice is to use a little bit of bleach in that pump to help clean some of that sludge out. But one of the things I have found is if you've already got a decent amount of sludge in the pump and all you do is just put bleach into the pump, when that bacteria and algae dissolves, it's going to make a mess, and it probably is going to gunk up the check valve or gunk up the motor. So I like using a condensate pump that has a removable base so that I can take it apart and actually clean the thing. And, you know, if you've ever gotten a hose on a shaded pole motor before, you know, they're a little bit forgiving.
Yeah.
So it is okay to take those things outside and to hose them off really good and then let them dry and then put them back together and take them back inside. So when you have a condensate pump that is starting to get a lot of algae in it, take it apart, take the thing outside and give it a really, really good scrubbing and then put it back together. So yes.
And to clarify what you're saying about that check valve too, that is a serviceable part. A lot of guys don't know that. A little, like, at least on Little Giant, it's got a little 6 flat hex that you just unthread it and it comes apart. You can clean it, or you can buy just the check valve.
The check valve.
As a service guy, I used to carry just an extra check valve on my truck.
That's a great idea. I'd never carried a spare one, but it completely makes sense because I've had some in the field that were, even though they were cleaned, they were still not seating properly. And so I'm sure there's a lot of pumps that get replaced that are unnecessarily replaced just because of a check valve. So very good point. Really good thing to be aware of. You know, another nice feature on a lot of these pumps is they actually have a separate safety switch as well. So if you want to tie that into an isolation circuit so that you can shut a system down or send an alarm into it, in the case of like a lot of the Goodman and Amana products that have a float switch set of contacts or an auxiliary set of contacts on the control board, you can actually use those contacts for that. So if we have a failed pump, we can actually shut the system down before we start filling the trough back up again.
Pull that piece of cardboard out.
You gotta pull a piece of cardboard out too. From the factory, they actually have a piece of cardboard slid in there with that. So yeah, definitely want to make sure that you do that one.
Going back on plenty of those.
Oh boy.
Just the cardboard was installed.
That's all it is, because it's just holding that. Because you think with that float, you know, if there wasn't something maintaining that float, it would just bounce around inside the packaging. So they typically put a little cardboard insert in there to keep that from moving around. Well, once water gets in there, we need that float to move around. So make sure to take that little cardboard insert out of that thing. So we carry a variety of pumps at Johnstone. Little Giant are my favorite. I've used those most of my career just because they are a well-designed pump. Now, we have different configurations of those, though, depending on your application. So that is the standard VCMA 20, which is, I'm sure, every Johnstone around the country has one sitting on their shelf. It has a decent amount of lift to it and a decent amount of volume, but your volume changes as your lift increases. So with this particular one, the motor is a 1/30th of a horsepower, so not a lot of power to that thing, but it can move a fair amount of water. If it's only going up 1 foot, it can move 80 gallons per hour of water. That's a significant amount. I don't know of any air conditioner that can move that much condensate. That's a well-tuned system if it is. At 5 feet, it can move 70 gallons per hour. 9 feet, it can move 55. And at 15 feet, it can move 25 gallons per hour. It does top out at about 20 feet. So at about 20 feet, the shutoff, it's basically seeing that it's drawing too much current on the motor. So at about 20 feet of pull, of vertical rise, it's going to go, man, this is just too much for me. And it will shut itself down. So if you have over 20 feet and you have a call that the pump is not keeping up or the pump is shutting down, take a look at the pump. It may be doing that to protect itself. We also have a shallow version of that. So that is the 20 ULS, the VCC 20. And so it is the same motor, it's the same top, it's just using a shallow trough, and it just makes a more compact installation. So a lot of times when we have, you know, a very short distance from our coil, we can use the VCC 20 and move the water. It has the same vertical rise to it, so it's using the same actual pump. It just has a smaller trough, a smaller reservoir. We also have a 230 volt instance of that. So if you're working with air handlers and you already have a 230 volt supply, we've got the 230 volt version of that as well. Same thing, 20-foot vertical rise on it. There's also the Clearview condensate pump, and the Clearview has a little bit of a difference to it over the Little Giant. So it's built by Diversitech, and Diversitech makes a lot of really, really good products. It is about the same. It has a 22-foot vertical shutoff. It's 120 volts. The interesting thing about it is it does not have an actual float switch. So it gets away from the mechanical float switch and just basically is using a sensor eye to read the depth of the water. And it's not using that shaded pole motor now. It's going to use a variable motor. It's going to use a variable speed pump. So the cool thing about it is that it can adapt its capacity. So it can, as it sees that the water is increasing quickly, it can actually change the RPMs of the motor to compensate for that. So it just adds a different feature over a standard mechanical float. So it uses the sensor and it uses variable speed technology to change the amount of water that it can move. So as far as energy efficiency, that is your most efficient, because if it doesn't need to move a lot of water, if it has a small capacity of water that it moves, it actually runs at a fairly low speed, and then it increases the speed as it increases capacity. And it uses that clear reservoir so you can actually see how much gunk is getting built inside of your reservoir. So a really nice design from Diversitech, and we keep quite a few of those around as well. We also have, now we don't stock a lot of these, but we have these at the DCs that can be delivered the next day in a lot of situations. We have our heavy duty condensate pumps. We go all the way up. If you look at that thing, that is a at 6 foot vertical rise. That pump is 550 gallons per hour. That's a dandy. That's a great yard pond pump. I mean, that thing is moving a lot of water. It's got standard mechanical compression style fittings for it, so you can hard plumb it. Or you would probably have to. If I only have 6 feet and I'm moving 550 gallons per hour through that thing on a 1/2-inch hose, that's got a lot of pressure to it.
Sure does.
Even at 20, if you look at that at 24 feet vertical rise, that thing can still move 462 gallon per hour water. That's a lot of water.
That's a lot of water.
It can run all the way up to 60 feet of vertical rise. That's a big deal. I can run 5 stories up with that kind of a pump if it was necessary. So if I'm in a situation where I don't have an easy place to get rid of condensate and I got to go 4 or 5 stories up to get rid of it, we have pumps that can do that. We even have them in multiple voltages. So if I look at this, that's the A5X 115. I also have an A5X 230 and a 460 volt. So it truly is a commercial and industrial application. All built by Hartell, which is really high quality construction, really good manufacturer, and all available to you. It's just probably not on the shelf.
Do you know if that's a split capacitor motor?
I would imagine it has to be.
Sure looks like one.
It does look like a PSC driven, which is going to give it that extra torque over that shaded pole motor. So I imagine when we pop the cover off on that, we're going to find a capacitor underneath that, because it sure looks like probably a 1/3 horse or 1/4 horse permanent split capacitor motor to me. Definitely, just looking at the windings through the casing and the ventilation. We also carry actual boiler rated pumps. So that's the thing you need to be aware of, is that a lot of the plastic pumps are not rated for steam or for high temperature, but we do have some that are. So we have, by Diversitech, we have these boiler pumps that are rated at 120 volts. They have, this particular one has a 46-foot vertical rise, so a pretty significant amount. The important part is that it's rated for up to 212 degrees Fahrenheit. So it can have a steam drip, because a lot of times on our condensate drips off from a boiler system that's a steam style boiler. We have steam that's mixed with water off from our drip, off from our release valve, off of the spigot. So the little boiler pump is actually rated for those higher temperatures. So we have to make sure that we are using a pump that's rated for the proper temperatures. Yeah.
steam humidifiers, I've seen those on. That'd be a good application. They
Perfect.
usually
I
mix
was.
some. They usually mix some cold water with them to cool it off before it comes
Yep.
down the drain. But sometimes it still gets pretty hot. So
I wasn't even thinking about that. That's a perfect application for a steam humidifier. Yeah, that you because you would need something that has a higher temperature resistance.
yeah.
Great application for that. We also carry some that have pH neutralizers built into them. So with the Nu-Calgon, that's the 4720-12, it actually has a standard float style pump with a reservoir that has replaceable neutralizing beads in it. Because we think about that water coming off from that furnace, right? Well, let's do a quick poll. With that water coming off from our furnace, what is the pH of the water coming off from a condensing furnace drain water? Have we ever even thought about it? I'm gonna launch a poll real quick. Let's get some ideas. That one. Is it a pH of 8, pH of 7, 6, 5? Have we ever even thought about it? I'll give it just a couple of minutes because it's kind of intriguing to me. Oh yeah, there's some interesting numbers. All right, so we have a majority of the people saying a pH of 5. We have some saying that it is a pH of 8. So if we think about the natural state of water has a pH of about 7. So anything below 7 is going to be acidic, and anything above 7 is going to be an alkaline. The interesting thing about acidity is its effects on health. So as we see the pH dropping, that's where, as far as water goes, we're going to find that it actually affects the composition of it, and it affects the things that can grow as well. So as the acidity and corrosiveness increases, so does the ability for additional bacteria and microbials to develop in that may not develop in the higher pHs. So what we end up getting is we get a lot of sludge in this acidic water because of its pH. So it tends to fall around 5. So an average condensing furnace falls in with a pH of about 5, but it can go as low as 3.5. And the reason it does that is if we think about that acidic water as it's sitting inside of, say, a trap, it has the ability to evaporate, right? So if it does evaporate along that process, then the pH is going to decrease. The acidity is going to increase because we're leaving that pH in the water, so the pH continues to drop. And it's a pretty significant difference. For every one number of pH, it's about a 10-time difference in the acidity. So from 7 to 6 is 10 times. As we go from 6 to 5, it's another 10 times. So it's multiplying in its amount of acidity. So the lower the acidity, the more abrasive that water is. So we use products to help neutralize that acidity, just like that condensate pump that we have. And we also have the inline filters that do that as well. We also, besides our unitary style pumps, we have another variety of pumps that we use for situations like mini splits that are compact style pumps. And there's a few of them out on the market. Sauerman has a variety of pumps, and Little Giant has a variety of pumps. And the ones that we tend to stock here, I'm going to show you a few of them. And they're actually recommended by Daikin. So we're going to pick on a Daikin mini split in this particular situation. So depending on the installation of your indoor unit, you could need a variety of different pumps. So let's just say that we have we have the scenario where we can actually put the pump in a serviceable location. You'll see this a lot when you get into commercial buildings, especially schools and hospitals, where they need to be able to service these pumps regularly, and they're on finished walls, finished structures. You'll see that pump sitting underneath of the indoor unit. That is so it can be easily serviced. But there are times for our installations that maybe we don't want that cosmetically. So in a residential application, we're probably not going to put an exposed pump. So we have a couple of options. We have an inline style pump that can actually be placed in the drain assembly. We also have some, so say if we're going to use a line hide or a concealed molding for our line set, we have some that fit in the elbow of that channel and still allows you to run your tubing through that channel. And then we also have external pumps as well, and most of those are higher capacity, and I'll show you those here in just a second. So we're not stuck with just one option when it comes to mini splits, and we can still use pH neutralizers in these as well. I'll show, I don't know if I have any, I don't think I added any for this one. I'll have to show you that one later. We've got some tablets that we can use. So a lot of times with mini splits, we'll actually put tablets in the drain assembly itself that is a neutralizing tablet. So if we look at the Aspen style, the one we use underneath of it that is the accessible or the cleanable and serviceable, that is, they call the white mini, and that unit is good for up to 54,000 of BTU. So pretty significant amount of water on a very, very compact pump. And that is a, that's designed for your exterior wall hung application. We've got the Mini Aqua. So the Mini Aqua is an inline style pump. So it has a small reservoir and then it has a separate pumping assembly. So it's a two-part unit so that it's easily installed in a small area, or I can separate my pump and my reservoir and have those, across the entire drain pan or underneath the unit. Real common one. We actually sell quite a bit of those inline Mini Aquas. We also have the Lime pump, which is the one that sits, and I like that one. It's a really, really convenient pump. And the nice thing about that is if you have exposed line hide that you're running your line set in, a lot of times that corner, that elbow is removable. It's usually got a couple screws, so you can still service this pump. It's just not as exposed. So it's a cleaner installation. Fits right in the corner of that elbow, and there's actually two different styles of it. There's a mini and there's a maxi, depending on the capacity of your indoor unit. So most of the time we're selling the little mini Lime. That's good for up to 54,000 BTUs as well. But they also have the larger capacity ones that go up to 157,000 BTU, and that is the maxi Lime. Mini Lime is a dual voltage, so it can be set up for 115 or 230, but the maxi Lime is a 230 volt only. Because if I've got an indoor unit that's running up to 157,000 BTUs, it's running on 230. It's not running on 150 anyhow. So both of those are available. We stock the mini, the maxi I've got to order in most of the time. We also have the orange. So the orange is rated for the same way. The mini orange is rated for 54,000. The maxi orange is rated for up to 157,000. But both of these are dual voltage. It can be ran at 115 or 230. Most of the time that is a remote installation. So say a lot of times if we're doing installations of mini splits, we'll use a wall sleeve. If you install a wall sleeve, it actually has a cavity already built so that you can set your condensate pump in that and actually set it in the wall behind the unit. So if you're installing plastic wall sleeves for mini splits, this is a good pump to utilize for that because you still have access to it behind that indoor head. Real common pump to be used is that mini and maxi orange, and we stock all of those. So just depending on the location of your pump will depend on what style you're looking for, and depending on whether you want it to be easily serviceable or not, because that blue, when you install that blue underneath of the unit, you're going to have to take the cover off to get access to it. That's the downfall, is that you're removing it. But if we're doing a proper cleaning of a mini split, we're taking the cover off anyhow, so it should be accessible to you. The Lime, that's going to be right in that line hide, so just take the cover off and we have access to it. The white one, the mini white that is in front, that's super easy to service it. The orange one depends on where we put it, because I've actually seen those orange set above a drop ceiling and have access to it through the drop ceiling. So we have a decent amount of distance from the indoor unit up to the orange. So it just depends on your actual application. It's got a heavy duty check valve built into that orange to help pull that water out of there. Any other comments on condensate pumps for mini splits or in general, Paul?
Just make sure you service them, keep them clean.
That's it, keep them clean.
They don't have the capacity as most condensate pumps and reservoirs, and so they get dirty fast and clog easy. So
they do. I recommend using those sanitary tablets on mini splits if you're using a condensate pump.
Yep.
Definitely saves the life expectancy of the pump. I bet y'all are thinking, how's this guy going to talk for half an hour on condensate pumps? Isn't there just like one or two? But we have a variety of condensate pumps on the market. All right. Oh, that's a good question for wiring configurations on pumps. That is a good one. So on our mini splits, you got to be very careful when we're doing our wiring, because with our mini split installations, we have communicating wires in there as well. So when we're tying the power on, we have to make sure that we're landing on the actual hot legs and not using like that third leg that is the communication wire. Because if we land on that communication wire, we will actually break communication for that piece of equipment and it will stop talking. So we got to be really careful to do that. I've actually had an installation not too long ago. I got a call from the technician that said, hey, it runs fine in heat, it runs good in air conditioning, but then just every once in a while, it just loses communication to the indoor unit. It just shuts it down. Any thoughts? I was like, well, maybe. Is that when the pump kicks on? Do you have it tied onto the communication circuit? And he had the neutral on the communication wire. So nothing was in effect until the switch made contact to turn the pump on. And when the switch made contact to turn the pump on, the communication network went, what? And would shut the indoor unit off and throw an error code on it. So make sure you're using the hot leg and ground or neutral to feed power to your pump. Good question. All right, everyone. I think we're going to wrap things up for today. I'll see if I can grab some wiring diagrams and maybe slam them in for the 4:30 one this afternoon and show some actual wiring diagrams. That's a good point. Thank you, Fernando. All right, everyone, have a great day. Be safe out there, and we'll talk to you the next time on Flex Train.
See you.
See you later.